when they found that ancient Greek computer thing, on what is that called?
The Antikythera mechanism.
Yes.
Yeah.
It's an analog computer. It doesn't use digital. It uses wheels and gears. This was a device that we wouldn't see again for another 2,000 years.
In 1901, divers pulled something out of a Greek shipwreck that nobody could explain. A corroded lump of bronze with gears inside. Gears so precise, so complex, so mathematically advanced that they should not have existed for another 1,400 years. This was not a clock, not a toy, not a decoration. This was a computer built 2,000 years ago, and what AI just decoded from inside it has rewritten what we thought we knew about the ancient world. A lump of bronze that changed everything. In the spring of 1901, a group of Greek sponge divers were working off the coast of a small island called Antikythera, sitting between Crete and mainland Greece. They had been diving the same waters for years. Then one of them went deeper than usual and found a shipwreck. The ship was enormous, ancient, lying on the seafloor at 45 meters depth, loaded with bronze and marble statues, pottery, jewelry, and coins. It had been there for roughly 2,000 years. Among the artifacts recovered was a lump of corroded bronze the size of a large dictionary. It was unremarkable. Divers set it aside. It sat ignored in the National Archaeological Museum in Athens for months. Then a researcher noticed it had split open, and inside the corrosion were gears. Not crude gears, not decorative gears. Precision-cut, interlocking bronze gears of a complexity that should not have been possible in the ancient world. Triangular teeth, differential gear trains, a pin-and-slot mechanism that would not be reinvented until Swiss clockmakers developed it in the 14th century. Nobody knew what to do with this information, so for decades, they mostly ignored it. The ancient computer nobody was ready for. It took most of the 20th century for researchers to piece together what the Antikythera mechanism actually did. The process was slow, painful, and repeatedly interrupted by the simple fact that over 60% of the device was missing, lost to the sea, dissolved by corrosion, or simply never recovered. What they had was fragments, 37 fragments of corroded bronze, covered in ancient Greek text, too damaged to read, and gears too fused to move. Working from this was like trying to understand a modern smartphone from a handful of broken circuit board pieces. But by the 1970s, using early X-ray imaging, researchers had established the basic function. The Antikythera mechanism was an astronomical calculator. You turned a hand crank on the side, and the gears inside tracked the movements of the sun, the moon, and the planets visible to the naked eye. It predicted solar and lunar eclipses. It tracked the 4-year cycle of the Olympic Games. It modeled the irregular orbit of the moon using a gear system of such mathematical sophistication that engineers who study it today describe it with something close to disbelief. This was built around 100 BC, possibly earlier, in a world where the most advanced timekeeping devices were sundials and water clocks. The next machine of comparable complexity would not appear for 1,400 years. The reconstruction that shocked everyone. For most of its history, the Antikythera mechanism was studied in fragments. Researchers understood parts of it, but the missing 60% meant the complete picture was always out of reach. Every reconstruction attempt hit the same wall. Too much was gone. In 2021, a team at University College London did something nobody had managed before. They used advanced imaging data, X-rays, CT scans, and surface imaging of every surviving fragment, and fed it all into computational modeling software. Then, they attempted to reconstruct the entire front plate of the mechanism, all of it, including the missing parts. The result was the first complete model of the Antikythera mechanism's front face ever produced, and it was more complex than anyone had imagined. The front of the device displayed a full model of the cosmos, as the ancient Greeks understood it. The sun and moon moving through the zodiac, the 5 planets visible to the naked eye, Mercury, Venus, Mars, Jupiter, Saturn, all tracked simultaneously, each on its own concentric ring, each moving at the correct speed relative to the others. The whole thing driven by a single hand crank, connected through a system of over 30 interlocking gears, all calculated to produce accurate astronomical positions. The engineering team that built the computational model described the gear system as, in their words, beautiful, not a word engineers use casually. What AI found inside the gears. The UCL reconstruction was extraordinary, but it still left questions. The gear ratios used in certain parts of the device did not perfectly match the astronomical cycles researchers expected. Some numbers were slightly off, some functions remained unclear, and the ancient Greek inscriptions covering the device, a kind of user manual written directly onto the bronze, were still only partially decoded. In 2025, researchers applied AI language models and pattern recognition software to the problem in a way that had not been attempted before. Instead of analyzing the device piece by piece, the AI was given everything simultaneously: every fragment, every gear ratio, every surviving inscription, every astronomical record from the ancient Greek world, and asked to find the connections between them. What it found answered questions that had been open for over a century. The gear ratios that had seemed slightly off were not errors. They were intentional corrections. The ancient engineers who built this device knew that the moon does not orbit the Earth in a perfect circle. Its orbit is elliptical. It speeds up when closer to Earth and slows down when further away. The Antikythera mechanism accounts for this using a pin and slot gear mechanism of extraordinary elegance, and the AI confirmed that the gear ratios are calibrated not to a simplified circular orbit, but to the actual observed behavior of the moon as recorded by Greek astronomers over centuries of observation. This is not a rough approximation. This is a machine built to model reality as precisely as the best observational astronomy of the ancient world could measure it. The hidden text nobody could read until now. The inscriptions on the Antikythera mechanism had always been partially readable, ancient Greek text describing the functions of various dials and displays, giving the device something close to an instruction manual. But large sections were too corroded, too faded, or too physically damaged to read with conventional imaging. AI changed this, using the same multispectral imaging techniques that recently revealed hidden text in the Voynich manuscript. Combined with AI pattern recognition trained on ancient Greek scripts, researchers extracted text from the surface of the mechanism that had been invisible for 2,000 years. What they found included something extraordinary: references in the text to earlier works, descriptions of adjustments made in later models, the language of iteration, of a technology being refined across multiple versions. This device was not the first of its kind. It was the most advanced surviving example of a technology that had been developed, improved, and refined over multiple generations. There were earlier versions, simpler ones, prototypes that led to this, and not one of them has ever been found. If the most sophisticated version ended up at the bottom of the Aegean Sea, where are the others? The mathematics that should not have been possible. The deeper AI went into the gear ratios of the Antikythera mechanism, the more remarkable the mathematics became. The device incorporates the Metonic cycle, a 19-year period after which the phases of the moon repeat on the same calendar dates. It incorporates the Saros cycle, the 18-year, 11-day cycle used to predict solar and lunar eclipses with precision. It incorporates the Callipic cycle, a 76-year refinement of lunar timekeeping so accurate it was the standard for Greek astronomy for centuries. These are not simple patterns. Establishing the Metonic cycle required centuries of careful observation, recording the position of the moon every night for generations, and finding the pattern buried in that data. The ancient Greeks had that data. They had been systematically observing the sky since at least the 7th century BC, but encoding all three of these cycles simultaneously into a single mechanical device, in gear ratios accurate enough to produce reliable predictions. That is something else entirely. AI analysis confirmed that the gear ratios in the surviving fragments are accurate to within a fraction of a percentage point. This is not a rough model. This is a precision instrument, and it was built with hand tools in bronze over 2,000 years ago. Who built it and why? Once you understand what the Antikythera mechanism could do, the next question is obvious. Who used it and why? The inscriptions describe it as a device for tracking the cosmos, for knowing where the sun and moon and planets were at any given time, and for predicting what they would do next. In the ancient Greek world, this had both practical and profound significance. Practically, eclipse prediction mattered enormously. Eclipses were omens. Military campaigns were planned around them. Political decisions were made based on them. A general who knew an eclipse was coming could use that knowledge to inspire his troops or terrify his enemies. The Athenian general Nicias famously delayed a retreat from Syracuse because of a lunar eclipse, a delay that led to the complete destruction of the Athenian fleet and arguably changed the course of Western history. A device that could predict eclipses weeks or months in advance was not a curiosity, it was strategic intelligence. But the Antikythera mechanism was also found on a ship carrying luxury goods, fine statues, expensive bronze, valuable cargo, traveling through the Mediterranean. The leading theory is that it was being transported as a high-value object, either a commissioned piece being delivered to a wealthy buyer, or a demonstration model being carried by a philosopher or astronomer. It was not a mass-produced tool, it was a masterwork, something that only the most skilled craftspeople of the ancient world could have built, and only the most powerful or educated would have owned. The centuries of knowledge buried inside it. The Antikythera mechanism did not emerge from nowhere. Behind it stands centuries of accumulated astronomical knowledge, careful observation, mathematical analysis, and a tradition of scientific inquiry that the ancient Greek world developed to a level that still surprises modern researchers. The gear ratios in the device draw on work by astronomers including Hipparchus, one of the greatest mathematical astronomers of the ancient world, who in the 2nd century BC produced the most accurate model of the moon's orbit that would exist for over 1,000 years. The device appears to encode his observational data directly into its gears. AI analysis of the gear system has also identified connections to Babylonian astronomical records, the systematic eclipse records kept by Mesopotamian astronomers going back centuries before the Greeks. The Saros cycle used in the device appears to have been derived from Babylonian observations. The Antikythera mechanism is in this sense a synthesis, Greek mathematical genius applied to centuries of Babylonian observational data, all compressed into 30 gears in a wooden box. This is what advanced science looks like in any era, not one person having a single brilliant idea, a tradition of knowledge building on itself across generations and across cultures, until someone produces something that seems impossible for its time. How much of this was lost forever? The most troubling thing about the Antikythera mechanism is not what it tells us about ancient Greek technology. It is what it implies about what we have lost. This device was recovered because a ship sank in a location that happened to be discovered by divers in 1901. The preservation conditions in that particular stretch of seafloor happened to be favorable enough that the bronze survived 2,000 years of corrosion with enough structure remaining to analyze. Every one of those circumstances was a coincidence. The inscriptions on the device reference earlier versions, prototypes, simpler models, a lineage of development that preceded this one. None of those earlier versions have ever been found. No similar device has ever been found anywhere in the ancient world. Not in Rome, not in Alexandria, not in Athens, not in any of the great centers of ancient learning. Ancient texts describe mechanisms of extraordinary sophistication, devices that tracked the heavens, calculated astronomical positions, modeled planetary motion. For centuries, historians assumed these descriptions were exaggerations or metaphors. The Antikythera mechanism proved they were not. What else was real that we dismissed as legend? How much of what the ancient world knew and built has simply not survived? Books burn, bronze gets melted down, wood rots. Most of what the ancient world produced is gone forever, not because it was never made, but because the materials did not survive. The Antikythera mechanism survived because it was on a ship that sank. That is the only reason we know it existed. What AI changed that humans could not? Before AI was applied to the Antikythera mechanism, researchers had spent over a century working with fragments, physically examining corroded bronze, debating gear functions, arguing about inscriptions, producing partial models that never quite fit together completely. AI changed the scale of what was possible. By processing every piece of available data simultaneously, imaging data, gear measurements, astronomical records, ancient texts, comparative analysis with other ancient instruments, it could find patterns and connections that no individual researcher could hold in their head at once. The 2025 analysis confirmed gear functions that had been disputed for decades. It decoded inscriptions that had been unreadable. It verified that the mathematical precision of the device was not approximate but exact. And it established definitively that this was not a one-off invention, but the product of a long tradition of development. What AI cannot do is tell us what happened to that tradition. Why, after producing the Antikythera mechanism, ancient engineering did not continue building on it. Why the technology appears to have died with the ancient world, leaving no descendants, no successors, no devices of comparable complexity for 1,400 years. That question, what happened, may be the most important one the Antikythera mechanism raises, and it is the one AI has not yet been able to answer. The ancient world was smarter than we thought. The Antikythera mechanism is a single object, one device recovered from one shipwreck, studied by one continuous thread of researchers across 120 years, and it has already forced historians to revise their understanding of ancient technology, ancient science, and the sophistication of the ancient world. Now AI is finding similar surprises in other places. Pattern recognition applied to ancient texts is revealing mathematical knowledge that historians assumed did not exist until much later. Analysis of ancient architectural remains is finding engineering precision that conventional tools should not have been able to produce. The picture that is slowly emerging is of an ancient world that was, in certain specific areas, far more sophisticated than our textbooks have acknowledged. Not because of lost civilizations or impossible explanations, because human beings have always been intelligent. Because given enough time, enough observation, and enough accumulated knowledge passed from one generation to the next, people find extraordinary things. The ancient Greeks had centuries of astronomical observation. They had brilliant mathematicians. They had skilled craftspeople who worked in bronze every day of their lives. The Antikythera mechanism is what happens when all of those things come together at the right moment. It is not a mystery that requires a miraculous explanation. It is a reminder that human capability, at its peak, has always been capable of producing things that seem impossible. And the fact that we nearly missed it entirely, that it sat corroded and ignored in a museum storage room for months before anyone noticed the gears inside, should make us wonder what else is out there, sitting in a museum somewhere, or still on the seafloor, waiting. The Antikythera mechanism spent 2,000 years on the bottom of the sea. It took another century of human effort and the full power of modern AI to understand what it actually was. And what it was is proof that the ancient world was doing things we had no idea were possible. What do you think? Is there more technology like this still out there waiting to be found? And if it is, what do you think it will tell us about ancient history? Leave your answer in the comments. Next week we are going to the pyramids. AI thermal imaging has found hidden chambers inside the Great Pyramid that nobody has ever entered. What is inside them, and why were they hidden, is what we are going to find out. Subscribe so you do not miss it. See you then.